Hi everybody. So in this video, we're going to look at a recurrence relation. And this is a way of defining a sequence where each term depends on the ones before it. We'll work through the examples in question 1, and then we'll try some exam style questions in examples 2 and 3. So for a recurrence relation, instead of listing out every number in a sequence from the start, a recurrence relation gives you a rule to find the next number using the ones that you already know. So if we begin with example 1, we want to work out the terms in this recurrence relation, and we've been given that u1 is equal to 1. So we need to find the next term, u2. Using the recurrence relation, this is where n will equal 1, because 1 add the 1 will give us this 2. So u2 will be 3 lots of un, so 3 lots of u1, plus the 2. And this works out as 5. Then the next term, u3, this is where the n will equal 2. So u3 will be 3 lots of u2, which we've just worked out as 5, plus 2. So this will work out as 15 plus 2, 17. Okay? And u4, this will be when n is equal to 3. So we'll have 3 lots of u3 plus the 2, and this will give us 53. So the first 4 terms in this sequence will be the 1, the 5, 17, and 53. And then for question B, we've been given u1 is 8, and we need to work out u2. So we'll substitute the previous term into here, and this is u1. So we'll have 8 over 2 plus the 5, and 4 plus 5 will give us 9. And then u3, this will be u2 over 2 plus 5, and this will give us 9.5. What do you think the next term will be? So u4 will be the previous term, 9.5, divided by 2 plus 5. And this will give us 9.75. So perhaps you want to try question C. We have a recurrence relation, and we've been given the first term in that sequence. Okay, so welcome back if you had a go. So u1, we're told is 2. So u2 will be the un, which is u1 squared, minus 1. And 4 squared minus 1 will give us 3. u3 will be the previous term, squared minus 1. 9 take away 1 will give us 8. And then u4 will have the 8 squared minus 1. 64 take away 1 will give us 63. Okay? In example 2, we're going to look at an exam style question. So we've been given a sequence defined by this recurrence relation, and we've got the first term as u1 equals 2. We need to work out u3 in terms of q, and then given that u4 equals 28, we need to find the value of q. So the first thing we'll do, we've got u1 equals 2, and we want to work out u2. And this will be where n is equal to 1. So u2 will be 3 lots of un, so 3 lots of the 2 plus the q, which will give us 6 plus q. u3 will be 3 lots of that previous term, u2, plus q. And we can simplify this. We'll expand out the brackets. So we get 18 plus 3q plus this one here. And this will give us 18 plus 4q. And this is u3. okay? For part B, given that U4 equals 28, find the value of Q. So we need to work out U4. This will be 3 lots of U3 plus that Q. And we're told that U4 is 28. And 3 times 18 will give us 54. Plus the 12Q. And this one as well. So 28 will equal 54 plus 13Q. We'll take away the 54 from both sides, and we get negative 26. And then we'll divide both sides by the 13, and we can see that Q will equal negative 2. Okay? Let's try another exam style question. So in example 3, we're given that the recurrence relation is defined here, and the first term is U1 equals 12. For part A, we need to show that U2 is 20. For part B, we need to work out U3 and U4. And then we need to try these questions for part C. So do you want to give these questions a go yourself? You can pause the video, and when you come back, we'll go through the solution. Okay, so I'll come back if you had a go. So to work out U2, this will be where n will equal 1. So we'll have U1 plus 6 lots of the sine of 180 times 1 over 2, so the sine of 90, minus 2 lots of negative 1 to the power of 1. And the negative times the negative will give us a positive 2. The sine of 90 is positive 1. So U2 will be 12 plus 6 plus 2. And this works out as 20. For U3, this is where n will equal 2. So U3 will be the previous term U2, 20, plus 6 sine of 180 times 2 over 2. This will be the sine of 180 minus the 2 times negative 1 squared. Negative 1 squared will make positive 1, so this will be minus 2. And then we'll have the 20. The sine of 180 is 0, so this term will go. And 20 take away 2 will give us 18. And then for U4, this is where n will equal 3. So U4 will be the previous term, which we worked out as 18, plus 6 times the sine of 180 times 3 divided by 2. And this will be the sine of 270 minus 2. And then if n is 3, this term becomes negative 1 cubed, which is negative 1, times that by the negative 2, and we get positive 2. So we'll have 18, so this becomes negative 6, plus the 2. So we've got 12 plus 2, this will give us 14. Okay? So that's parts A and B. And then for part C, given that the sequence is periodic with order 4, work out the value of U5. So if it's periodic, we'll have the first term as 12, the second term is 20, then we'll have 18, and then we'll have 14. And these will continue to repeat. So you can see that U5, the fifth term, will be equal to the first term, and this will equal 12. And then for part 2, find the sum between r equals 1 to 25 of this recurrence relation. So we know it's periodic, so this will be the same as between m equals 1 to 24, because 24 is a multiple of 4, plus the next term, 25. Well, the terms between 1 to 24 will be 6 lots of these. So we'll have 6 multiplied by the 12, plus the 20, plus the 18, and the 14. And then we need to plus the 25th. But the 25th one will be the one at the 12. And then when you add up this bracket and you multiply it by 6, we get 384 plus this 12. So the sum of the first 25 terms will be 396. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.